happens when you multiply two terms. Now we're going to talk about what happens when you divide two terms. And so when you divide two terms, essentially what you do is you subtract their exponents. Okay, let's look at this visually. N to the fifth means you have 5 n's, right? Isn't that what n to the fifth means? What does n cubed mean? N times n times n. And so really, what ends up happening now is if you look at that, you have a numerator and a denominator. We have some things in common. So we can cancel those out. We can cancel one of those n's out. We can cancel another n out. We can cancel another n out. How many does that leave us with? 2. So really my answer would be n squared. So then the question is, how do you get 2 from 5 and 3? You subtract them. So that's the visual reasoning behind why you subtract the two exponents. Okay. Let's go ahead and look at an example. Simplify. G cubed h to the fifth over g h squared. Now notice I don't have a power here with the g. So what is it implied to be? 1. Okay. So then now, what do I end up doing with the g's? Subtracting them, and what do I have? 2. Okay, what do I have for the h's? H to the third. Good job. That's it. You're done. Let's look at another one. This one's got multiple ones. Okay, that table back there, you're responsible for this one. What am I going to get? Okay. Yep. Okay, or just p. I could write p or p to the first. Same thing. Good job. There you go. So all we did is subtract the 7 and the 5, the 10 and the 3, and then the 2 and the 1. Okay, so now what we're going to talk about is we're going to talk about the power of a quotient. And if you notice there, to find the power of the quotient, find the power of the numerator and the power of the denominator. So basically what's going to happen here is you're going to distribute whatever the power is to both the numerator and the denominator. That's all you're going to do. So I'm going to distribute this power here to the numerator and to the denominator. So really what that means is that I have 3p cubed, that quantity squared, divided by 7 squared. So now you learned how to do the 3p cubed squared, the one that's on the numerator. You learned that a couple days ago. And basically that means you square both the 3 and then you square the p cubed. If you square the 3, what do you get? 9. Okay, because remember it's 3 times 3. If you square the p cubed, what do you get? P to the 6th, very good. Divided by 49. Nice job. Now you can't reduce the 9 and the 49 any. Nothing is in common between those two. So you just leave it as 9 over 49. Let's look at another one of those. Now, what I did on the previous example is I showed you kind of the reasoning behind it. I'm going to show you a little trick that I do, okay, to solve these. I actually distribute that 3 to both the 5, the x, and the y. So if I distribute it to the 5, that means 5 times 5 times 5, which is
75.
Close.
65.
125, okay? So then now let's distribute the cubed to the x to the 5th. What do you get when you distribute the cube to the x to the 5th?
15.
X to the 15th, because you multiply them. And then what do you get for y? the third. So we distributed it on the top. Now we got to do the same thing on the bottom. What do you get on the bottom? 216. And there you go. Questions? What do you think so far? Okay, I want you to go ahead and try this one, and then I'm going to ask for somebody to go ahead and give me the answer.
If we can reduce it.
Yes.
you want us to.
Yes. All right. This table, only one person, you get to come up with the answer. All right, what'd you get?
64 x to the 9th
Okay, good.
over 125 y to the 12th.
Is he right?
Yep.
Good job, because we distributed that cubed to each the 4, the x, the 5, and the y. Okay. 3 to the 0 power. Is it 3? Is it 0? What is it? You've all got a calculator on hand. You are looking for the y to the x cube. Okay, so you can like type 3 and then you can hit your y to the x key and hit 0. What do you get? 1. Here's something to file away to memory. Anything, any quantity, anything to the 0 power is always 1. If I had 1,234,567, if I had that big number and I went to the 0 power, my answer is 1. Anything to the 0 power. If I had a quantity, if I had x cubed over y squared to the 0 power, the answer is 1. Okay, this is something that will follow you through your other classes. So let's go ahead and look at this. Okay, real quick, what do I know the answer is? The answer here is 1. Look at how complicated it is. The answer is 1. You don't even have to do any more. Okay, and so now what we're going to do is we're going to kind of reverse our thought. We're going to go to the top of the slide, and we're going to talk about what a negative exponent is. Basically, what a negative exponent is it means it's located in the opposite location. Okay, it means it's located as kind of the reciprocal. So here, a to the negative n is 1 over a to the n. So really, what does that mean? If I had x to the negative third, that means 1 over x cubed. You put it in the other location. If now you had a fraction, and I had 1 over x to the negative third, it's in the denominator, but to make it positive, I'm going to put it in the numerator. So my answer here would actually be x cubed. So wherever the negative exponent is located, you put it in the other location. So we've got a few examples. We're going to look on that, and then we'll be done. Okay, so I have n to the negative fifth, p to the fourth, over r to the negative second. N to the negative fifth, p to the fourth, over r to the negative second. So now, I see I've got a negative exponent here. n to the negative fifth. Where am I going to move that? To the bottom. Okay? So really, I've now got an n to the fifth in the bottom. What about the p to the fourth? It stays put. Okay, what about the r to the negative second? Okay, it's a negative, so I'm going to move it up here. So I'm going to go ahead and have p to the fourth, r to the second, all over, and to the fifth, and that is your answer. Oops, sorry. Didn't mean that. So far, so good on that negative. Do you understand where that comes from? Okay. Ooh. Okay. I'm going to let you write that down. Biggest thing we're going to do is take this step by step. The first thing I'm going to deal with are the numbers. I've got a 5 and a 20. That's a fraction, right? What goes into both 5 and 20? 5 goes into 5 one time. 5 goes into negative 20, negative 4 times. Okay? So I took care of that. So really, I now have negative, and notice what I'm going to do. I'm going to move that negative up. I now have negative 1/4. Okay, because remember, we don't answer negatives in the denominator. So let's look at the top. I have an r to the negative third. Where am I going to move that? To the bottom. So now I'm going to put an r cubed. What am I going to do with the t to the fourth? Leave it on top. Okay, so now let's move to the bottom. What am I going to do with the r squared? Keep it at the bottom. What do I do with the t to the seventh? Keep it at the bottom. What do I do with the u to the negative fifth? I move it up top. Now our goal there was to reduce the fraction and then put everything where it should be. Now we're going to combine things if we can. First of all, I'm going to leave the negative 1/4 alone. Notice here on the top I have a t to the fourth, right? And on the bottom I have a t to the seventh. I want you to visualize in your head. T to the fourth means I have how many t's on the top? 4. How many t's on the bottom? 7. So I'm going to have some cancel, right? How many left over am I going to have? 3 where? On the bottom. So that will be my t cubed. Do you see how you can kind of visualize and see? Okay, let's look at the next one. U to the fifth, do I have another one? Nope, so it stays on the top. Now the only thing I have is on the bottom here. So I need to think. I've got 3 r's here, 2 r's here. How many do you have?
1.
5 on the bottom. No, because these are times. You have r cubed times r squared. It's not like one is over the other. Okay. If you would have subtracted them, it would have had to look like this. Okay, but since they are times, you add them. All right, let's look at another quick one, and then we'll call it good for today. All right, so we're going to follow the exact same procedure we did in the previous problem. We're first of all going to reduce the fraction down. Then we're going to move things to where they need to be positive, and then we're going to simplify. Okay, so let's start by reducing down. What number goes into both 5 and 25? 5 goes into 5. 5 goes into 25. 5 times. So far I now have 1/5. Okay, let's start kind of moving some things around if we can. The j to the negative third, where do I move that? I move that to the bottom. What about the k squared? Keep it. What do I do with the m to the negative sixth? Down to the bottom. Okay. What do you do with the k to the negative fourth? Move it up top. And what do I do with the m to the negative second? Put it to the top. So now we need to simplify individual terms. So let's go ahead and look. I have a k squared and a k to the fourth on the top. What does that make? K to the sixth, because you have 2k's and 4k's. All right, I have an m squared on the top and an m to the sixth on the bottom. So 2 m's on the top. How many on the bottom? 6. What's going to be your net result and where? 4 on the bottom. And then what's the only other thing I don't have accounted for? The j cubed. And there you go.
So remember, like if there's like a 1 6 on top and then 2 at the bottom, and you put the 1 4 on top.
Mhm.
Doesn't matter if like you have like inverse and
No. Generally, they always put things alphabetical, but on this one, I'm not going to be that picky. Okay, so here you go. Page 403, I need you to do 20 through 56, the evens, not number 44.